Hey guys, here for video 2 over solving quadratic equations using square roots. Start with the problem 3x squared minus 3 equals 0. If you notice, I've already found the variable x there. I've highlighted it in pink, and now we have to solve for that. To do that, we are going to undo everything that's being done in this problem. Usually when we solve problems, like I said in the last video, we use PEMDAS. But since we're undoing this, we're going to go backwards and do PEMDAS backwards. So the first thing to do is get rid of that minus 3 by adding 3 to both sides. And those would cancel out. I'd add 3 here. And I'd be left with a 3x squared equals 3. Then I look at what's happening on the left-hand side. I have 3 times x squared, so I have to undo that multiplication by dividing both sides by 3. Divided by 3, divided by 3. 3 divided by 3 is 1, so they cancel out. I'm left with x squared equals, and 3 divided by 3 on the right-hand side is also 1. And now I am left with just x squared equals 1, and the inverse of squaring a number is taking the square root of that number. So I'm going to square root both sides, and I am going to be left with an answer of x equals 1, but that's not my final answer, because please remember that when I do these problems, the square root of 1, or the square root of 1 asks you what number times itself equals 1. Well, 1 times 1 is 1, but so is negative 1 times negative 1, so my answer is plus or minus. In other words, a positive 1 or a negative 1 are both my answers. If I go on the right hand side over here, I have 2m squared minus 42 equals 8. I find my variables m right there, and I have to undo everything that is being done to it. So I would start by doing addition first. So I would add 42 to both sides. My two 42s would cancel out because one's positive, one's negative. That would leave me, I don't want that, that would leave me with 2, let's just scroll down a little bit more, 2m squared plus 50. I lied, not plus 50. 2m squared equals 50. Sorry, guys. Now I would have to divide both sides by 2. My 2's would cancel out, and that would leave me with m squared equals 25. So I'd have to take the square root of both sides. My square root and my squared would cancel out, leaving me with just m, and my answer would be a positive or negative 5 or a plus or minus 5. So the answer to that problem is m equals plus or minus 5. Go to the next example. Let's just zoom in on that one, possibly. So I have to undo what's being done in my problem here. So I would start off by subtracting 11. Zoom in a little bit more, sorry guys. Minus 11 and minus 11. My 11s would cancel out. That would leave me with 25b squared equals 4. I would then have to divide both sides by my 25 to get my b squared alone. And my 25s would cancel out, which would leave me with b squared equals 4/25. And if you guys have noticed yet, we get to this step on every single problem. The last thing we will always have with these problems is just our variable to the power of 2. And to solve all of these problems, we will just have to take the square root of both sides. My squared and square root cancel each other out, and I'd be left with the answer of b equals a positive or negative, like all these problems, 2/5. Because the square root of 4 is 2, and the square root of 25 is 5. So the answer to that one is b equals plus or minus 2/5. And let's scroll over to our next example. 5n squared minus 17 equals negative 9. If you notice, these are pretty repetitive. They have a very similar process to solve all of them. I would add 17. I would add 17. My 17's cancel out. That leaves me with a 5n squared equals a negative 2. I would divide both sides by my 5, divided by 5, divided by 5. 5's cancel each other out. That would leave me with n squared equals a negative 2/5. I would have to get rid of my squared sign, my exponent of 2, by square rooting both sides. And those cancel out. But here is where we get to a little bit of a conundrum, or something that's kind of interesting. We've talked about in the past, you can't take the square root of a negative number. There is no way to multiply a number by itself and you get a negative answer. A positive times a positive is a positive, and a negative times a negative is also a positive. So if you are ever left with n squared equals a negative number, or x squared or any variable equals a negative number, your answer simply is just going to be no solutions. And if you go back to the very first slide, it has an example of what happens when it says d is less than 1, and it says that your answer will be no solutions on those as well. Okay. Let's go on to the next slide. The directions on this slide are a little bit different. It says solve the quadratic equations using square roots, round to the nearest hundredth if needed. So if I zoom in on the first problem, I would have to isolate my variable term, which is my x squared. I would do that by subtracting 6 and subtracting 6. Those cancel out. I'm left with x squared equals 7. I would have to take the square root of both sides in order to get rid of that power of 2. Those cancel out, leaving me with just x. And for these problems, once again, it still needs to be plus or minus, because d is greater than 1 here, or d is greater than 0, sorry, and whatever the square root of 7 is, positive times positive and negative times negative will both be our answer, so it will be plus or minus. This is where you guys can 100% definitely use a calculator, and for the sake of time, I'm just going to tell you guys the answer is 2.65 is the correct answer on that one right there. Okay, moving on. This one looks a little bit different because now our variable is on the right side of the equation, but that makes no difference at all. There's my variable right there. I have to isolate that term first, and then isolate the variable itself. So I would subtract 8, possibly subtract 8, maybe subtract 8, subtract 8, and I'd be left with 45 equals 9m squared. After I do that, turn that off. After I do that, I have to divide both sides by 9. They cancel out. I'd be left with 5 equals m squared. I would now have to take the square root of both sides. And I'd be left with m equals, because I like to write my variable first, plus or minus 2.24. So once again, you can use a calculator on that. Just make sure you follow the directions. If it says round to the nearest hundredth, please round to the nearest hundredth. If it doesn't, don't. Okay. Let's do a couple more like that right here. I would start off by, there's my variable, and before I can isolate that, I have to isolate the entire term it's in. So the first thing I would have to do here is add 5, maybe, add 5, add 5. They cancel out. I'm left with 4b squared equals 7. Divide both sides by 4. They cancel out. I'm left with b squared equals 7/4. In order to get that b by itself, I have to get rid of the exponent of 2. I do that by taking the square root of both sides. And I'm left with b equals plus or minus 1.32. Nope, wrong thing. And last example on the slide, I have 9n squared minus 14 equals negative 3. Once again, there's my variable. I have to get its term by itself first. So my first thing I have to do is add 14 to both sides. They cancel out. I'm left with 9n squared equals 11. I would then divide both sides by 9. Divide by 9. They cancel out. I'm left with n squared equals 11/9. I will then take the square root of both sides. Those cancel out, and I'm left with n equals a plus or minus 1 and 11/100. Hopefully those made some sense for you guys. If not, rewatch the video, email me, contact me on